There's antimony, arsenic, aluminum, selenium, and hydrogen.
Hello everybody. Today we are going to look at a demonstration of types of matter, how we can combine these types of matter to look at different classifications of matter that's all based off of the properties of the matter that we have. We're going to be working with two elements, and I have samples of those two elements here on the lab table. Here I have iron. Iron is a solid gray colored powder. A property that you probably know about iron is that it is magnetic. Iron conducts electricity. Iron is also flammable. Iron is flammable. The second element that we're going to be working with is sulfur. Sulfur is a yellow-colored powder. It's more of a powdery substance. It is not metallic. Sulfur has a little bit of an odor to it. Sulfur is also flammable like iron is, but sulfur is not magnetic. These two forms of matter are pure substances. Specifically, the type of pure substance that they are is an element, meaning if you would look at a periodic table, you would find sulfur, it's element number 16, and you would find iron, it is element number 26. They are both pure substances, they're both elements. But we're going to take these two pure substances and begin to combine them. So here I have a test tube rack, okay, with a couple plain test tubes in them. I'm going to take the sulfur powder. It's on a piece of weighing paper, that's what we call this, and I'm going to slide it into the test tube, like that. And I'm going to add the iron to it on top of it, like that. Okay, like so. So I have the two kind of mixed, but I want to begin to mix them a little more. So I'm going to kind of tilt the test tube and begin to spin it, slide it down a little more and tilt it up and continue to spin it like so. So we are beginning to try to mix these substances like this. Okay, now what I have here I would classify as a heterogeneous mixture. The two substances, the two elements, the iron and the sulfur, are mixed together, but I can clearly see what part is iron and what part is sulfur, because they are different colors. Again, the iron is a grayish colored substance, the sulfur is a yellow colored substance, and we could see what those differences are inside of the test tube. That's what makes the mixture heterogeneous. Something else that's characteristic about mixtures is they retain their properties. So a common property that we know about iron is the fact that it's magnetic. This is a mixture. So in a mixture, iron should still be magnetic. So here I have a magnet, just an ordinary bar magnet. And I'm going to take the bar magnet and hold it up to this test tube and try to draw it up the side of the test tube, and you could see it pulls the iron out of the mixture from the sulfur, like that. Okay, if I pull the magnet away, all the iron falls back down. But if I take the magnet and hold it back up to the test tube and slide it upward, it begins to pull all of that iron out, meaning the iron can be separated from the sulfur physically. Physically, meaning we could use the physical properties of iron to pull it out from the sulfur, like that. The next part of our demonstration is we're going to take our iron-sulfur mixture, again a heterogeneous mixture, and we're going to heat it. We're going to heat it over a burner flame inside of a hood and watch what happens when we do that. Okay, so I have a pair of test tube clamps. I'm going to clamp onto the test tube like that. Going to light the burner. And I'm going to turn the lights off in the fume hood so we can kind of see this better. And I'm going to begin to apply some heat to the iron-sulfur mixture, like that. And what I'm doing is I'm going to begin to look for a glow inside of the test tube, right about there. At this point, I could cut the heat from the burner, and we see the test tube continues to glow, because what is happening now is the iron and sulfur are reacting chemically. Okay, finally, our last step. This is after the heating. We have allowed the test tube to cool, and we have actually broken the test tube to get the product out, because it often sticks to the glass. But this is what we now have. And what this technically is an iron sulfide compound. It's a different form of matter. It's a substance with a different composition and different properties. It's still a pure substance, but it's no longer an element. It's a compound because the iron and sulfur have combined chemically. So they now have formed a compound. Compounds have a different composition. They have a different set of properties. Notice the substance has a little bit of a different look to it, but the main thing I want to show you now is if I take our magnet that we used earlier and I run the magnet over top of this, nothing is magnetic. Because when you make a compound, compounds have a different set of properties than the elements that make them up. There's iron inside of here, but it's no longer elemental iron. And the iron that's inside of this compound is no longer magnetic. It has undergone a chemical change. It is now a new substance.